me share the screen, the slide first. Let's see how the slide looks like. Okay, picture 15, hazard control. For this chapter is, if you look at the slide, there are mostly in words. You should read about these slides. Okay, then today we are going to discuss, right? So what I'm going to do now is to I have gone through this. I have gone through these slides, and I have some key points for you to discuss. Okay. So today I'm not going to go through one by one of this slide because you can actually do this on your own. The slide is available in the UKM Folio. Instead, what I'm going to do is to basically to explain. Okay, to explain to you the elemental or the key points from this chapter, and I'm going to use this platform, Google Jamboard. So we are in hazard control. Sekarang ni kita nak we're trying to look at the methods or some ways to control the hazard. When we're dealing with hazard or when we work under the hazardous conditions, we are dealing with the process. Yang pertama kali, proses tu sendiri could be hazardous. The chemicals, the process conditions, pressure, temperature. Satu. Next is the people. Okay, orang ataupun workers yang handle the activities, the task. Okay, proses dah mungkin berbahaya, orang mungkin dia pun ada bahaya, mungkin human error, perangai orang yang tak suka tak menitik beratkan keselamatan. And orang juga boleh jadi the public, okay, the public around the facility. Kedua, yang ketiga is the system itself ataupun the surrounding ataupun the system tu sendiri, sistem keseluruhan yang melibatkan proses and human. Okay, so ada tiga benda. Because of this, we want to see one by one how to control the hazards throughout these three things. Okay, how to control the hazards by controlling the process, and then by controlling the people, and then by controlling the system itself. So that's what this chapter is talking about, hazard control. Okay. So if you read the slides, or actually this slide is coming from your textbook. If you read this slide, it's the same with this textbook. You will see that there are three controls in principle to perform the hazard control. There are three approaches. So how would I do this? So hazard. Pen saya yang salah. So apa yang tiga tu apa? One is engineering. Okay, engineering control by engineering. Okay. Second is what? Ada yang dah baca slide tak? Satu engineering, yang kedua by admin kan? Administrative control, betul tak? Engineering control ni the things that involve the process itself. And the third one is legislative. Tulisan saya ni masalah sikit. Saya punya pen ni masalah sikit. Tapi you can boleh tengok lah. Kita ada tiga controls, engineering, admin and legislative ataupun by rules, by acts. Okay, so in engineering, we want to see the process control, the operating parameter, the chemicals involved. Okay, admin ni, we want to enforce the people. We want to control the behavior of people. that are exposed to the hazard. Legislation is by means of law, which is the system itself. Okay, so dalam if I can add slide. Okay, hazard ni, in any industrial process there will be some hazards involved, kan? Okay, so kita nak reduce the hazard. Okay, kita nak reduce the hazard as low as possible, betul tak? And to reduce this hazard up to the point that there is no hazard at all, if possible. Okay, but the question is how? Betul tak? How and what are the costs or what are the expenses to reduce this hazard into non-hazardous condition. So this will be the roles of the engineers, especially safety engineers, chemical engineers, process engineers, design engineers, to ensure that the hazards of the process has been reduced as low as possible. Okay, so that's why in engineering it will involve these three hazard control. Okay, so if you read the slide, there are three principles on this engineering control. First is normally we do the enclosure. Second is isolation, and the third is ventilation. That is in general. And you can see that is in engineering control, the steps or the methods of hazard control itself is actually built into the process, and it is part of the process equipment. Betul tak? Kita design any safety precaution which is built into the process. Kita guna utility, cold water, ataupun the process itself, we make sure, let's say the process is endothermic, so we supply the cooling jacket, for example. If the process is exothermic, we supply the cooling jacket. If the process is exothermic, what do we do? How to release the heat? We need to think about it. Okay, through the heat exchanger and so on. Okay, that means the safety precaution is built into the process. Okay, contoh kalau fire, okay, kalau hazards, sekarang kita tengok dekat engineering yang lain you can ignore first. Kalau hazards is in terms of fire, kebakaran, what do? We install detector ataupun sprinkler system ataupun alarm system. Okay, so the safety precaution is built into the process. Kalau the process involves toxic materials, kita pakai apa? Kita pakai same lah, toxic chemical substance detector and also the alarms. Okay, so whenever it passes the threshold limit or the limit, the alarm will ring. Right, so if we, okay, maybe kalau saya boleh ringkaskan from the slide, how do we eliminate or how do we start this engineering control? Yang pertama sekali, kita nak, kalau boleh kita nak eliminate the hazard, betul. So from saya punya pen ni masalah sikit. Okay, so eliminate the hazard. Kita nak eliminate the hazard. That means this is the first step. If possible, we want to clear from the avoid the hazard. So if this is possible, sorry, my so why ni yes that means if we can eliminate the hazard, that means our process is very safe. Saya boleh katakan 5 saya bagi 5 levels of safety. Okay, sebab kita dah eliminate hazard. Let's say kita tak boleh eliminate the hazard. the hazard is still there, we have to tolerate. So kalau no, selalunya kita akan pasang, usually we will design the safeguard system. Okay, safeguard. Saya rasa memang tak boleh lah saya punya ni, so I'll use the sticky note. Okay. So kalau tak boleh, kita safeguard. Maknanya kita encounter the hazards by the response. Okay. Macam kalau in terms of process control semua tu kan. Okay. Kalau tak boleh safeguard juga. So in this safeguard here, kita dah ada lebih kurang dalam 4 lah. 4 safe. Tadi 5 kan sebab kita eliminate. Okay. Kalau tak boleh juga safeguard. If safeguarding is not possible, means yang ni pun no. What do we do next? Protective safety devices. Dia cakap apa? Protective safety devices. We make use of the safety devices. Okay. So I can put one more sticky note here. Safety devices. Okay. Right. So kalau hazard is reduced, and if the protection safety devices is practical, that means dia berjaya mengurangkan hazard, that means we are tolerate. Kita boleh tolerate lah. 3. Safe. Let's say protective safety devices pun tak berjaya untuk turunkan hazard. What do we do next? Ini yes, ini no. What do we do next? Usually we install the warning ataupun automatic warning devices. Okay. Auto warning devices. Kat sini. Okay. Macam if you are working with ammonia processing, you need to, it is compulsory for you to wear the CO detector, carbon monoxide detector, because for example, after the conversion of syngas into carbon monoxide, or the carbon monoxide from the feed itself is very dangerous to your lung system. So even at a small concentration of carbon monoxide, you need to detect them. Okay, auto warning devices. So if it's more than the threshold, the detector will ring some noise. Okay, bunyi lah, dia bunyi menandakan CO level is high. So that's how you control. So semua ni engineering ni. Okay, semua ni engineering sebab kita tengah discuss engineering approach. Okay, kalau berjaya, that means we can tolerate. Kalau tak boleh juga. Okay, somehow the auto warning devices are not so efficient, then we come to the last option, which is the PPE, the individual punya preparation lah. Okay, personal protective equipment, and then regarding the SOP, okay, PPE procedure and training. Okay, so this one will be the least option we can do. So we have all this stage. Then kalau over here the hazards has been reduced significantly, then we can tolerate or we can satisfy. We can proceed with the process, the industrial process. Okay, that's how the level of control that we want to achieve in any industrial process. We start with the first. We want to eliminate the hazard as low. Eliminates mean no hazard at all. Kalau boleh. Kalau tak boleh kita buat step by step. Tak boleh juga sampailah jadi PPE. So basically when you enter any chemical plants and the moment that you wear the PPE, okay, macam kalau plant tu bising kan, you pakai apa tu yang dekat telinga tu, tutup telinga tu kan, or you wear your goggles, that means you are already at the least control. Can you see that? Kan, ketika masuk plant, let's say you are bekerja dalam plant, the moment you enter the plant and you are wearing your PPE, that signifies that the control is already at the least option. Betul tak? Kita dah tak boleh eliminate hazard, tak boleh safeguard, tak boleh safety device, tak boleh auto warning. The least we can do is to wear your PPE. Maknanya the risk is getting higher, but we have done as much as we can. Okay, so that's what it means. So along this process, if you look at along this process is the engineering control. Okay, we look at the process itself and we try to control step by step. All right, so what are the examples of engineering hazard control? Dekat sini. Saya pun dah confused. Dekat sini. So I can give you a basic mind map lah dekat sini, okay? Some examples of engineering control. You can actually read this in the slide. Okay, kita ada, I'm going to write down in simple acronym sajalah sebab ada dalam slide kan. First is intrinsic safety, dan saya punya pen ni ada masalah sikit hari ni. Intrinsic safety ni is one of the engineering hazard control. That means the safety is built into the design. It's not an add-on. Okay, intrinsic. Okay, dia berbeza sikit dengan another IS, which is inherent safety. Inherent safety pun we want to avoid the hazard, but this part is involving the chemistry and also the physics of the substance involved. Okay. And in inherent safety, we avoid the hazard. We do not control the hazard, but we avoid them. Kalau intrinsic safety, the safety is built into the design. It is not an add-on. So ada beza sikit lah. Okay, other examples you can tengok dalam slide tu, kita ada fail safe design. Okay, FSD, fail safe design. Ada diceritakan dalam slide. Bermaksud when undesirable things happen, like we have set a certain benchmark for the or a certain limit for the process, and we do not want the process to exceed the limit. Okay, but unfortunately, if it still exceeds, then the system will trigger the fail state. Okay, or the fail safe. Okay, the fail maknanya dia dah tak move on until we have to reset the process. Okay, fail safe design. Saya rasa kalau the closest example like it's similar to flare lah, flare. Kalau kita something happen and the feed is being, let's say the flammable feed is being processed, we do not want the feed to be untreated dalam produk punya stream kan. So we feed in fail safe design, the feed will be passed to the flare. Okay, for example. Next is redundancy in engineering control. So in redundancy ni, dia macam backup lah in any certain chemical process. Contohnya, so the system will run normal after a unit fails to operate. Walaupun satu unit tu for some reason dia fail to operate, we have backup so that the process tu tak kacau. Okay, macam backup pump, backup recycle flow. Okay, so this redundancy control, engineering control is important when your process is continuous and when your process is involving when continuation is critical. Dalam proses tu, nak tak nak, you have to continue the process. You cannot stop the process. So you must control the hazard by redundancy. Ada backup. Okay. Next is weak link. Okay. Weak link ni apa? Contoh yang paling senang nak faham ialah fuse electric. Okay. So this involves the electrical hazard. Okay. Bahaya renjatan elektrik. In fuse, kalau ada short circuit kan, kalau ada litar pintas ataupun overflow of current, fuse tu akan terbakar dulu. Okay. Fuse tu akan terbakar dan dia tidak akan mengakibatkan pengaliran arus yang berterusan. Maknanya dia akan stop the electricity. Kan, I'm sure your house has this safety system. Kalau during the kalau kilat kan, kalau kilat tu kuat sangat, dia akan trigger this fuse. Fuse tu bukan fuse, dia macam ada sistem dia untuk stopkan the electricity from the main plug. Okay, so weak link. Okay, weak link. That is for electrical. Kalau for mechanical, structural pun sama. Okay, kalau mechanical, weak link dia would be in the form of shear stress, kan, pressure. So ada bahan yang dia punya shear stress dengan pressure yang lemah. So that can be used as a weak link. Okay, kita akan buat dia sebagai response ataupun to indicate some response for certain hazards. Structure pun sama. Kalau chemical macam mana? Apa weak link dalam chemical? Boleh jadi flash point kan, we make it as a benchmark for a temperature, okay, ataupun the volatility. So it depends on the process lah. Alright, weak link. Next is alarm. Okay, alarm system ni is straightforward lah. Dalam engineering control pun kita pakai alarm system. So if you are working as a control engineer, most of the time you are working in the main control building, MCB, facing the DCS, right? Distributed control system. And when things go wrong, you will hear some alarms. Okay, so that is in control room. If you are outside around the plant itself, often you will hear some alarms when undesired things happen. Okay, ada loceng keselamatan. Okay, next is process upset control. Process upset control. Okay, PUC, process upset control. Yang ni you are more familiar in this lah. We have even discussed this during our previous chapters. Kita tengok kalau contoh hazards in chemical spill, kan, fuel spill, which is the liquid fuel. So we install some, we call it what, dikes. Okay, dia ada macam pagar to avoid the merebak, chemical fuel tu merebak ke sekitar. So kita sekat oil spill tu menggunakan dikes. Okay. Ataupun yang flare tadi, process upset control. Sometimes when you are dealing with complicated process, okay, and the process is so complicated that if one unit is upset, it will trigger some instability for the other units. Okay, and you have to control this. One of the way is by flaring the feed, macam tadi lah, kan. Kalau satu sistem tu upset, one way is because your feed is continuous. Kalau you work in oil and gas punya downstream, the feed is continuous. You cannot stop the feed because it's coming from the supplier, and the supplier itself, macam mana cakap this SCM, supply chain management. Let's say, okay, I always give you example on ammonia kan. Kalau ammonia, the supplier would be syngas, same gas producer, macam Petronas Gas. Petronas Gas dia akan bagi syngas to ammonia plant continuously. Kita akan stop, continuous. So you as a process engineer dekat ammonia plant, for example, kalau berlaku apa-apa upset dekat your process ataupun unit, you tak boleh call PGB apa proses Petronas Gas, PGB kan, Petronas Gas Berhad, telefon dia kata, oh kita ada masalah, we have to stop the feed. No, you cannot. Sebab PGB will always supply you the continuous feed. So what to do when your process is upset? You burn the feed. You have to burn the some of the feed in order. So that means you have to kena tanggung lah kerugian tu. So feed tu instead of jadi produk, dia dah jadi apa? Combustion punya produk. Is useless. Okay, so process upset control. Apa lagi? Sprinkler kan? Sprinkler system, explosion, suppression. Dalam slide tu ada banyak lagi contoh lah. Right? And then monitoring. Monitoring system. Monitoring ni is also straightforward. You use CCTV or the measuring flow meter, measuring flow lah, temperature and so on. Kita monitor. Ada monitoring system. Next is isolation. Isolation, interlocks, lockout. If you Google interlock kan, interlock in safety. Some picture. I want to show you something. Yeah, something like this. Sometimes kita nak tunjuk yang the process has been locked. Maknanya jangan kacau. Okay, jangan kacau. How to say? Lock. I think the term is lockout. Macam ni. Ni. Danger. Do not operate. Okay, sometimes we use this interlock system to control hazards by engineering control lah. So maksudnya bila a certain operator ataupun certain operating valve kita nak elakkan daripada operator lain buka ke tutup ke kan. So we use this interlock apa dipanggil lockout. Okay. So bila operator dia rasa dia nak buat sesuatu, dia tengok ni tak boleh kacau. You cannot sentuh langsung, jangan kacau. So this is also one of the steps lah in engineering control. Okay, sama juga for this one is lockout kan. Where is the slide? Interlock is here. Isolation, lockout, lock-ins, and interlock. Itu lockout. Isolation ni yes, isolation means kita separatekan the hazardous process. Kita tak sekali kan. Lockouts yang tadi, lock-ins pun lebih kurang kita lock juga. Interlock ni macam mana? Okay, interlocks ni it means kita kunci proses tu disebabkan satu trigger telah berlaku. Nak bagi senang contoh is your washing machine. Okay, satu proses condition berlaku, you cannot do anything until the process is done. Interlock. Kalau washing machine, waktu you dry when you dry the clothes, mana nak keringkan baju, selalunya mesin basuh ni bila kita start dry, kita tak boleh buka lid tu. Pintu apa ni mesin basuh ni tak boleh buka sebab dia dah interlock. Okay, so that is for washing. Dalam chemical process pun ada interlock. So we cannot kacau any valve anything until it has been finished. Okay. Right, so let's go back to our discussions ini tadi. Apa lagi? Interlock dah. So that's all untuk legislation. Engineering means we control the process itself, the reaction ke apa kan dalam proses tu sendiri. Okay, administrative control in hazard control So administrative ni pun straightforward lah. Saya pun baca slide tu, you can actually understand by your own. How can I say? Admin ni we can actually divide the administrative control by two. Okay. Pertama ialah programs, administrative programs, and the second is administrative activity. Okay. So program dengan activity. Oh, saya punya pen ni lagi makin lama makin teruk Tapi you can see lah. First is program and second is activity. So beza dia program ni administrative control by program ni maksudnya is a written document. Selalunya ada hard copy, okay? Ataupun dia dah lekat dekat frame, dekat dinding when you enter the plant ataupun you enter the industrial punya workplace. Dia lekat dekat dinding ataupun dia dah print siap-siap kepada workers. It's a written document. Written document that explains how hazards are to be controlled. Ada tu di dalam slide. Contohnya permit PTW permit to work punya sistem. Okay, PTW punya sistem. That means you cannot do your work unless you have obtained the permit. That is part of the program. And then the training program pun boleh jadi the administrative program. And also the evacuation plan. Okay, kalau berlaku sebarang kebakaran, letupan ataupun any incidents, how are you going to evacuate the building? So there is a standard printed document for that, guideline for that one. Okay, so administrative programs involve policy, standard operating procedure, okay, SOP, and rules and regulations at the workplace. Okay. Examples of the administrative program would be dalam slide tu ada banyak cerita lah, some example. But before we go for some example, let's go to activity dulu. Administrative activity ni apa? Administrative activity ni, control by administrative activity means the program juga, okay? The programs that has been put into action. Kita execute the program. Okay, nak bagi senang apa? Kalau administrative program is about fire evacuation plan ataupun evacuation plan during the fire incident, then the administrative activity would be fire drill. Okay, program is the evacuation plan, activity fire drill. Maksudnya kita buat fire drill to ensure that the workers are following the program. Itu beza dia. Okay, sama juga macam toxic release ke apa. Activity would be the toxic release punya drill lah. Okay, so other than that, examples of program ni kan. Program ni examples dia, cardinal rule. Cardinal rule Cardinal rule ni means we warn the workers or the management warn the workers what would happen if they violate some major incident, kan? Kalau dia buat sesuatu dekat plant, dekat chemical plant, menyebabkan penalty yang sangat tinggi, kita panggil cardinal rule. Contohnya, okay, sebelum tu penalty ni dia boleh jadi suspension, dia digantung daripada bekerja, ataupun dia diberhentikan daripada bekerja. Cardinal rule. Contoh, the rules about alcohol drink. So the employee cannot bring any alcoholic drink during the workers' time. Or the drugs, dadah, tak boleh bawa dadah, tak boleh bawa senjata api, tak boleh merokok. So cardinal rule ni is some kind of administrative control with program punya type. So kalau the workers insist dia nak merokok juga ataupun dia bawa senjata, that means they will face a very heavy penalty. Cardinal rule ni is not it's not official. Dia tak adalah kata agreement. Maknanya macam act ke apa ke. Tapi it's some kind of binding between the workers and the employee. Dia tak wajib tapi selalunya ada lah in chemical processing plants. Okay, what else for the program, administrative program? Mutual aid agreement. Memang tak boleh pen saya ni. Okay. Mutual aid agreement. Saya kena pakai mouse. Okay. So this is also another type of administrative program, hazard control. That means a mutual agreement between the manufacturer ataupun the management of the chemical plant with the local government punya authority. Okay, dia akan saling membantulah untuk in terms of safety punya aid. Okay, safety punya countermeasure. Okay, kalau berlaku ketidakcukupan ambulan, for example. Okay, for this local clinic ataupun hospital, then dia akan ada agreement with local government to back up with some more ambulance. Kalau tak cukup fireman, okay, dia akan deal with the local government to provide more fireman, bomber. Ada bomber yang akan backup. So in order to aid the safety punya incident, okay, pun is part of the admin program. Okay, selain daripada tu, apa lagi? Buddy system. Buddy system pun admin punya program juga. Administrative control by what we call this program. Buddy system you boleh faham lah. Especially when the workers are dealing with confined space. Okay, macam closed tank, they want to do some maintenance, so it's not safe to go alone. Okay, kena ada teman lah. Maybe okay, in buddy system in the slide, if you can read the slide, dia ada dua cara. Yang pertama, sama ada dua orang kan, seorang masuk dalam confined space, for example, seorang lagi buat inspection kat luar ataupun standby dekat luar confined space tu. Okay, so dia tengok kawan dia ni ada sebarang tanda-tanda yang menunjukkan bahaya ke tak, sesak nafas ke apa ke. Okay, satu cara lagi, dua-dua masuk. Okay, dua-dua berdepan dengan hazard, and they will dia akan saling bantu, saling monitor each other. Dua orang ni kan ada empat mata, dia lagi inilah, bahaya tu lagi boleh dilihat lah. Okay, so ada dua cara. Not just for confined space, it can be in any task in industrial process. So buddy system will be very good for the safety. Okay, kadang-kadang kalau kita buat alone, kan, betul tak? Kita pergi buat maintenance work alone, seorang-seorang. If anything happens, then macam tu je, sedar-sedar one people is missing, kan? Masa nak buat head count ke, buat drill ke, ataupun in the logbook, one people tak clock out. Sedar-sedar dia dah pengsan sebab dia seorang, tak ada buddy. Okay, so buddy system is part of the administrative control in program, administrative program. What else? Warning, mean and devices. Okay, warning, mean and devices ni I'm going to go straight to the slide sebab ini pun is straightforward. This one, right? Ini melibatkan how do we communicate with the people ataupun user about the hazard by giving them signals of warning, kan? Okay, so I'm going to go straight to this. So this is examples of warning, means and devices. Selalunya dia akan ada color code lah. Okay, safety color. If the color is red, that means it's prohibition. That means you cannot do that, you cannot do this. Okay, no smoking, no fire ignition. Okay. Kalau if it's yellow or amber, usually it's a warning. If it's blue, it's mandatory. kan. It's mandatory to wear the goggles, for example. If it's green, that means it's a first aid or emergency escape. No danger, but it's part of the safety evacuation plan, for example. And in most cases, kalau dia merah, then it's relevant to firefighting. Okay, some symbols are here. So these are examples of mandatory signs that display a specific behavior message or action that must be carried out within the designated area. Okay, ini kalau tempat tu bising. And this is mandatory lah. Mandatory for you to wear all these things. So it depends on the nature of the processing jugalah. Okay, but in most chemical plant, they will produce some noise. Okay. Safety boot, okay, sarung tangan. Ni pelitup gas ni kalau you are in a confined space or in hazardous gas punya environment. Okay, and this would be the sign to warn the visitors. So it's a warning, yang yellow tadi, staff and the public of possible dangers and hazards. Okay, toxic chemicals, api, flammability, mudah terbakar. Okay, or in general danger macam ni. Okay, falling object, corrosive material, or biohazard. Okay, and then this one, certain behaviors and actions are prohibited. Ini menunjukkan macam yang tadi kan kita tengok kalau red ni, red for the prohibition. Okay, dia ada red untuk fire and red for prohibition lah. So this is red for prohibition. Tak boleh, dilarang merokok, dilarang masuk tanpa kebenaran, dilarang menyalakan api. So dilarang lah. Everything is about prohibition. The red one. Okay. And this is the green one, although there is no danger or no hazards, tapi it's part of the hazard evacuation. Okay. Kalau apa emergency shower, okay, eye wash, and this is just a reminder lah during the in the chemical plant. Okay. And sometimes you see this signal, so you see this symbol, tempat berkumpul semasa kecemasan. Okay. Okay, so let's go back to this. Tadi saya dah tunjuk apa? Warning, mean, and devices. Okay. Warning, mean, and devices. Okay. Next is apa? PPE. Personal Protective Equipment punya program. Okay. PPE is also part of administrative program. And the management of any industrial process must have a PPE program. Okay, and they must enforce this PPE program in any industrial, even in our campus, academic punya industry kan. I mean, academic punya surrounding environment dekat your lab. The management has to enforce a program untuk menyatakan pentingnya untuk pakai PPE, pakai lab coat, wear your goggles. Itu kalau di campus. So if it's in industrial punya plant, lagilah kena ada enforcement. So it's part of the admin program. Okay. So we are done with the administrative program. Next is administrative activity. Macam tadi saya kata, activity ni beza dia dengan program ialah we put into action. Kan? Kalau the administrative program is about fire evacuation plan, then the activity is fire drill. Apa lagi contoh lain? Housekeeping. So now we are here. Now we are here. We are in administrative activity. Contohnya housekeeping. So if you are working under a research center, selalunya akan ada frekuensi sebulan sekali, 2 bulan sekali untuk housekeeping. Sebab when you do research, kadang-kadang sampel-sampel tu dia tak terjaga. So kita buat housekeeping, kita susun elok, kita kemas, kita cuci semua. Kelas-kelas wear. Sama juga dekat chemical industry, industrial punya ni. Memang ada housekeeping punya schedule. Okay, and dia akan ada rotation lah, which team to do this for this time, and then for the next week or the next month, team mana pula yang akan handle housekeeping. So keeping the program into action. Okay, inspection, buat inspection dekat process units. Audit, okay, safety audit for the for your process lah, for safety audit, ataupun safety investigation, okay, ataupun dalam slide pun tulis hygiene monitoring, how hygiene is your workplace, okay, kotor ke, kan, do you handle the trash properly, emission monitoring, okay, you check the emission level in your combustion product, for example, okay, and sometimes we have workers observation. Kita suruh je, I mean the safety officer dia suruh je pekerja-pekerja tu buat kerja macam biasa, as usual, cuma dia monitor, and then at the end they will come out with the report. Betul tak apa yang pekerja tu buat? We call this workers observation. So those are some activities, okay, some actions ataupun administrative activities to control the hazard. Macam yang boleh tengok lah, admin ni sebenarnya kita dealing with the people lah sebenarnya, administrative control ni, kan? Kita nak educate people on safety perspective. Kalau engineering tadi on the process itself, kan, kita control process, kita ada some mechanism for trigger and so on, kan. Yang ni people, orang tu sendiri. Sebab orang ni macam-macam, ada yang bagus, ada yang tak suka safety, kan. And the final one is legislative. Legislative ni sebenarnya saya tak maulah pergi in detail sebab memang kita dah belajar pun sebelum-sebelum ni. I think in chapter 3 ke chapter 2, kita dah belajar in details what are the acts, akta-akta yang kita dah cover. Akta-akta yang berkaitan macam-macam EQA, Petroleum, FMA, Factory Machinery Act, Petroleum Act, those kind of akta lah. So nak katanya legislative ni pun kita cuba untuk control hazards by means of law. Okay, we establish a good system, okay, a law, acts, akta. Okay. Jadi apa yang ni legislative ni you can read the slide very. In fact I'm going to go through the slide lah right here. Where is it? Very quickly. Alright, admin control. So these are activities kita dah cover tadi. And final one, yeah, control by legislation. So we have some very well-known acts macam FMA, Factories and Machineries Act 1967, Petroleum Act, OSHA. Okay, kalau you Google memang ada complete document for each of these. Right. So these are some points for each act. Okay. Ada setiap pecahan tu ada some guidelines and rules and regulations. Okay. Boleh baca. And even you can read further by checking out these documents. Kalau lead ataupun timah ke lead ni, asbestos. This is OSHA. Kita pun dah belajar OSHA hari tu, dah discuss dah. OSHA ni dia antara employer dengan employee. What they have to do to ensure a safe working environment and also safe behavior. Okay. Ya, kita dah discuss ni sebelum ni. Duties of employer, duties of employee, what are DOSH officers kan? This is the responsibility of employees. So I'm going through this very quickly. Okay, so we go back to our apa mind map yang tak berapa cantik ni kan. Just to clear to see the big picture. We control the hazards by means of three ways: by engineering, by admin, or by legislative.